All right. Okay, so these 2 hours we will discuss for the Form 5, Chapter 1 and Chapter 2. All right. So these 2 chapters, previously it was in the Form 4 syllabus. Right. So now it put into the Form 5, but the content is not heavy. I think in the Form 5 syllabus, these 2 chapters is the most easier. All right, so have a look first. Okay, so for the chapter 1, okay, it basically is split into the 2 different parts. Right. The first part we will focus on the forces equilibriums, right? Which is we focus on the how to find the resultant force with the different methods. Okay, and the next part, okay, chapter 1, we're going to focus on the elasticity. Right, so there's a basics of the 2 different parts. If you're referring to the formula list provided, okay, so for the last year exam, right, all the 3 formula for this chapter, okay, which is force and motion 2, is totally on the second part. It's about the elasticity, right? Elasticity. So with the formula F equal Ks, and then the elastic potential energy, okay, with the 2 different formula. So I don't know why it provided this, right? So I don't know why it's provided this, because basically you just need to provide E equal to 102 Fx, enough already. Because from here, okay, when we substitute F equal to Kx into this formula, then we will get 1/2 Kx squared. Right, so by right, number 3, no need to give. Okay, it's just an extra one. Okay, and when you apply the number 3, okay, for the elastic potential energy, usually the students have a mistake because of the x squared. All right, so it forgotten to square the extension. Okay, so this one later we go through the elasticity. So I will touch again. So it means that the first part for the problem dedicated to the resultant force and the methods to find that resultant force is not given any formula, because we just only the concept to apply F equal to ma. Right, it's a concept F equal to ma. So since that we already know from the Form 4 chapter 2, okay, which force based on the Newton's second law, right? F equal to ma, and the force is a vector quantity, so have the direction. So, and this Form 5 is going to focus on the solving on the forces acting on the different direction with the different methods. Okay, so okay, this is one that we call it resultant force. When we find the solutions, okay, once we get the solutions presented okay, for all the forces acting on the object presented by the single force. So that single force we call it resultant force, as the meaning is given here. All right, so you have to make sure that you know the definitions. The resultant force is a single force represent the vector sum two or more forces acting on the object. All right, okay, so we start from the very basics for the discussions. Once that the force they are in parallel. Parallel means that either they are same direction or either they are opposite directions. Right. So once they are in parallel without any angle, so means that the angle in between is 0 degree. 0 degree either is the same direction or either opposite direction. So you can easily find the resultant force by the total bit by additionals, or the just subtract, then you can get the resultant force. So when they are opposite directions, same magnitude, so the resultant force equals 0. When the resultant force equals 0, so many students just only remember when the resultant force equals 0 is it will cause the system stay stationary. They forgotten one thing. When you have the resultant force equal to 0, means that you have the ma equal to 0. So ma equal to 0 is not because of the m equal to 0, it's because of the a equal to 0. And the a equal to 0 have the 2 possibility. Either it stay at rest. That's why we get stationary. Or either v constant. So we have the 2 possibility. Okay. And then if you recall back the question that I asked during the trial exam, right? So the I think it's about the hot air balloons, if you still remember. So because the hot air balloon is moving forwards, then due to that, many of you choose, right? The forward force is bigger than the backward force. The problem is when the hot air balloon is moving forward with a constant velocity, so the force forward and backward is the same magnitude, opposite direction. Resultant force equals 0. So there's no such thing that the forward force bigger than backward force. So please make sure collect the concept. Okay. Okay, and then this is the most basic one. Okay, when they are same direction, we just total up it, okay, as given here. And obviously just subtract. And then the direction. Example, in this case, when we assume that to the left is negative, so here we have the negative 8. And to the right is positive. So once we total up these two, means that we have total up 6 plus negative 8. So you got the result is negative 2. When you have the negative 2, means it follows the negative directions, right? So like that. You also have the options, you can do it by 8 minus 6. So it means that we put the 6 as a negative directions. All right, so that's why minus 6. So we take this one as a negative 6. And then this is a positive 8. So in that case, you will get the answer equal, to 2. So it means the answer is positive 2. Positive 2 means it follows positive direction. It's still the same. Only the way how you look at the negative direction and positive direction in your solutions. Right? So there's nothing is right, nothing is wrong. Okay. But because this one you find it's just want to know the resultant force and the direction itself. So but it's not that difficult yet. You can simply put the positive or negative. But when it happens on the impulsive force, as I mentioned before this, okay, when especially in the paper ones because you have no any room for you to give the explanations on your assumption. So it happened in the past year also. Okay, when like this case like this one also said, when this is a question asked in the paper one, and then you look at the answer options, there's a one positive 2 and one's a negative 2. So in that case happens, you have to assume follow the common assumption, which is to the right is positive, to the left is negative. You cannot simply change it. All right. So therefore, your answer only accept will be negative 2. So for me, it's quite bad because the question is no mention. The question is no mentions anything about the positive direction, negative direction. So it assumes that student know and student able to apply the common assumption. All right. So what to do? All right, you just follow. Okay, and when they are not in the parallel way, so we will start with a very simple one. When the two forces in perpendicular. When the two forces is perpendicular, all right, so we're going to solve it by the particulars theorem, right, which is we find by the hypotenuse. All right, so for the hypotenuse calculation, so we're able to know the resultant force as given here. Okay, so this actually it can be considered as a triangle methods like games already. This one considered as a triangle method like games already. Okay, so later we will go through the drawing methods how we find this resultant force. Okay, and from here we can see that the student are required to answer the to find the angle from the x-axis, how much the theta for the resultant force from the x-axis. Right. So last time in the old syllabus, actually they removed this part. Okay, so now in your textbook it's introduced again. So, but I don't really think that the questions will ask you to answer also how much the degree, how much the angle for the resultant force. Okay, but even it asks just only the extra calculations. There's nothing difficult here. Okay. And now another one, we have the situation where the two forces, they are not perpendicular. When they are not perpendicular, so we're going to solve it by the three different methods. Right, either with the triangle of forces methods or either with the parallelogram of forces methods. Okay. For me, okay, to solve drawing methods, triangles of forces methods will be easier for the drawing methods, because the parallelogram for forces methods, normally we only use this to solve resultant force when there is only two forces add on the objects. Okay, only two forces add on the object. So we will use a parallelogram. But it doesn't mean that when you have more than two forces, you cannot use the parallelogram. You can use also. Only the methods are slightly different, right? You have to draw more than one parallelogram in the solution. Later I will discuss about this. Okay, triangle of forces methods, it can be applied to find the resultant force for any numbers of forces acting. More than two, okay, up to 5, 6, 7, 8. Also no problem. We can use the triangle method forces to find the resultant force. Right. So when we use this drawing methods to find the resultant force, you have to fix the ratio. Right. If the question doesn't fix for you, you have to fix the ratio in your drawing. So it means that you have to know every single centimeter that you draw presented how many force. Right. So we call it stress diagram. So you have to fix it. Okay. If not, then it's just by labeling, then your answer will be wrong. Right. So look at the example here. Is that mentioned? No, not mentioned. Right? Okay, so it's for the discrete diagram. All right. So okay, look at here. For the triangle of forces methods, you just need to remember we start from the 1 point. We start from 1 point in our drawing. From this point, we can choose any kind of any force in the question itself, get as a starting first force. All right. You don't necessarily must follow the labeling F1, F2, F3. You can choose anyone as your first force they're going to draw. All right. Normally, we will choose either horizontal or either vertical. Okay, it will be easier for us to draw it as a first force. Okay, once you finish the first force, once you finish the drawing with the ruler, once you finish the drawing, at the ends of this force, we continue the next force. Okay, so let's say continue the F2 here with the anchor given, specific anchor that we have already. So let's say we have the F3. So F3 is going down. Let's say F3 going down, so we follow. Okay, we're going to continue here, going down. Depends on how much is the magnitude of the force lah. Right. So this is where we get the F3. And after we finish F3 already, let's say you have another F4. You continue it with F4. So let's say F4 in this way with the anchors that you know, theta. Right. So now if you done the F4 finish here, right? So that is your starting point. This is starting point. Here is the ending point. Then from the starting to ending, you join straight line, starting to ending with the direction like this. So when measure the length, that it will that one will become your resultant force. That one become your resultant force. So that is the advantage when we're using the triangle of forces methods. All right. So it's not necessarily must be in triangles lah. All right. It's just the names only, because usually we only use it to solve 2 or 3 forces. It may become triangle. So that's why. Okay. But for the parallelogram, okay, parallelogram, we only every time one parallelogram we only can solve 2 forces. All right. So like this case, after we draw F1 and F2 already, we're going to draw another parallel line at the end of F2 here, parallel line with F1. All right, parallel with F1. So after that finished, and then you're going to draw another one parallel with F2. All right, parallel with F2. So this is one parallel with F2. So then you follow the arrows, so you will know that it's starting from 1 point, okay, ending at the other point. So this will be the solutions. This one will be the solutions for the F1 and F2. This will be solutions for F1 and F2. So here it becomes the temporary resultant if we have more than 2 forces. Okay. So I use the blue color. Okay. So this one is a solution for the F1 and F2. F1 and F2. Okay, so it's a one solution. And this solution, we're going to, let's say I follow this another F3 here. So we continue with F3 here. This is F3. So we draw another parallel line, F3. Then after that, we draw one parallel with this temporary solution for the F. Okay, so we follow the ratio line. So this is what we this one will be the F marks also. So in that way, you will get another second solution. So second solution from here to here. So maybe I use a green color. All right. So this is another one solution. Okay. So this one become our second solution. All right. So if we have no F4, it's only F3, then this second solution will become our final resultant. All right. So if we still have the F4, then we continue draw another F4, follow the anchor. So maybe it's like this. All right. Maybe like this, like this. All right. So then after that, you follow this, follow the directions. Then you will get another final resultant. Use a black color. So this one this one will become your answer. This will be the resultant force, right? So you're going to draw like this, right? So that it will become the many parallelogram mixed together. All right. So, but don't worry, this is out of your syllabus lah, of your label. So your label is not going to draw the solution for the parallelogram like this way. Okay, usually we will use a parallelogram to solve to get the resultant force for the two forces. All right, we're not going to do this. I just show you the way how we apply it to solve resultant force for the more than two forces. Okay. So this is the drawing method. Okay, and then the calculation method, we call it these solutions of forces, which is the one in the 1.2. All right, the one in the 1.2. So before that, okay, so here's some example about the resultant force for the parallel forces setting. Okay, so example for this one, when the object's falling down. All right, object's falling down. So for object falling down, okay, when have the air resistance, so it will be acting opposite direction towards the gravitational force add on the object, which is a weight, downward weight. So when we minus it, so we will get the resultant force downward. So that's why the coconut is still accelerate downward because of the resultant force. Okay. And for the lift system, this system you will see sometimes you have to be the R minus W, sometimes we have the W minus R, right? So all because of that. When depends on the lift situations. Okay, if the lift state at rest or up and down with a constant velocity, means the resultant force for the whole system equal to 0. When the resultant force for whole system equal to 0, okay, when the moment is stay at rest or constant V, up or down. All right. So the resultant force equals 0. So in that case, means we have the R equal to W. Right, just like the question B. All right. So when R equal to W, so the R will show the result for the mg. So imagine that there is a weighing machine here. So let's say there's a weighing machine. So when you stand on the weighing machine, when the moment the lift is at rest or up and down with a constant V, then the weighing machine, it will be as a normal reactions, which is the our result, right? So our result, normal reactions. So it will be show you the actual weight. But these readings will be changed. The R will be changed when the lift is no longer stay at rest or move with a constant V. So if the lift accelerating upwards, is the lift accelerating upwards? When the lift accelerating upwards means we have the R is more than W. Because now when accelerating upwards, okay, showing that they have the resultant force upwards. To have the upward resultant force, then the R will be bigger than W. Therefore, to find this F resultant force equal to MA, So then we have to make sure the MA is equal to the R minus W. So from here, the R will become MA plus W, which is the MA plus MG. So that's why the reading show on the weighing machine as a normal reactions, it will be bigger than your actual weight because our actual weight is only mg. But now what is experienced is MA plus mg. Okay, so that's why the all the pilots or the astronaut, when the rockets or the pilot flying the jet, when you accelerating upwards, so you increase the body weight because of that. All right. So when you watch a movie like the Top Gun, okay, so it mentions that when the jet is accelerating going up, so it mentioned the increasing of becomes a 1G, 1.5G. So that is meanings of the double up the gravitational pull, right? So that it will increase the weight experience, right? So same also when the moment diff accelerate downwards, when the diff accelerate downwards, so we will have the downward resultant force because the diff is accelerate downward. Therefore, we will experience W more than R. So W minus R will become the MA. Okay, so the R will equal to the mg minus ma. Right. So with that, then you will have the lighter weight, especially when the moment, let's say the cable is snap. Okay, the cable snap, the diff is fall down due to pull of gravity. Then your A become the G. So once A become the G, so at the end you will resultant the no result the reaction force, normal reaction force becomes 0. So it means that you won't feel your weight when the moment is free falling down. All right. So because the reaction equals 0, then the moment you feel very less. Okay. Right, before you are going to help, okay, after the lift landing. All right, okay. So example 3. Okay, example 3 that we still can solve it as a parallel force. Even from here, we can see there's a one acting horizontally, one acting vertically. But why? Okay, but why we still can consider it as a parallel? Because there is a string link. It's linked. All right. So once it's linked, okay, even from the ligand itself, it look like acting in the two different directions, but because it's linked with the string, so it's still considered as a parallel force. Okay. So in this case, you have to remember for all the hanging object, it will experience the weight as a kind of force acting on the system. The trolley also have the weight, right? But the weight of trolley, it doesn't affect in the calculation because the trolley is moving horizontally. Trolley is moving horizontally. So, but the weight of the trolley would acting vertically. So after we derive it into the horizontal, so it will back to 0. That's why the weight, it doesn't affect the horizontal motions, right? Okay, so due to that, this weight we can just ignore it, right? So what we have to alert is once have a string connect, then you must always remember when the string connect, you must have the tension that concentrate towards the center of the string itself. So this tension will be acting in the concentrate to the center in the two different directions. Okay. So when we want to find these tensions, okay, or the any reactors, example, when we want to know about the accelerations of the system. So let's say example like this. If that okay, so here given the frictions force, so we have the opposites here, 6 Newton. And it's told you already the trolley move with an accelerations, okay, with acceleration, so means the trolley accelerate here, have an acceleration 4 meter per second. So means the root also accelerate downwards 4 meter per second because they link. So once the link means when the trolley accelerate, so the root also accelerate. Okay, so this is how we solve. So means that for the case like this, you have to remember the common quantity for the both object trolley and the root they have the two common quantity. First one is the tension. Tension of the string connect with the trolley, and the tension the string connect with the root is the same. Another one's a common quantity for the both is acceleration, because when the root, how much acceleration experienced by the root, actually it will be same as acceleration experienced by the trolley. So remember, this is a two quantity commons, okay, commons experienced by the both objects. Okay, so once we want to solve it, okay, I advise my students, okay, do not follow the solutions given in the textbooks lah. Okay, so I don't really like the solution given here. So and basically I don't really read through. Okay, I just hope that my students learn by split it become the two system. Once it split it become the two system, then you will see the solutions like this. Means that you have the trolley here. The trolley experience the fractional force 6 Newton, and then have the tensions forwards. So at the same time, this trolley have the acceleration A equal to 4. Okay, 4 meter per second per second. So this is what we have. And then for the root, we have the weight, and then we have the tensions, and it's accelerate downwards equal to 4. So now with that, we form our own equations. Our own equation rests on the resultant force concept. So the tensions definitely have to be bigger than 6 Newton because we have the acceleration. So it means that the resultant force acting this way. This is the resultant force. And this one also same, the resultant force acting this way. So remember, resultant force all equal to MA. So in this case, for the trolley, we have the MA is equal to the T minus 6. All right. And for the root here, the MA is equal to the W minus T because MA is facing downward. Okay, only the mass for the both is different. So this one is the mass for the trolley, and this is a mass for the root. Okay, so others, they have the same common T tension, it's the same for the both sides, and they have the common acceleration, which is equal to 4. All right, so later on, you just solve it by the simultaneous equation, then it can be done. All right, so either you want to find the A first, or you want to find the tension first, up to you lah. Then we just only apply simultaneous equations. You just rearrange it. Usually we will rearrange it, make it become T equal to what? Example, this one T equal to the M A plus 6. Then this one, rearrange it, become the T equal to W minus MA. Right? So if you back to the question here, how much the M? M for the trolley 1.2. Alright, so we don't have the root. Okay, we only have the M for the trolley is 1.2. Right, so the trolley is 1.2, then it's equal to 1.2 multiplied 4 plus 6. Right, then we solve it here. So we have the 4.8 plus 6 is a tension, become 10.8 Newton for the tension. All right, and come to here, we have the 10.8 tensions. When we solve it here already, they come to here. So we have the mg. So mass of the root we don't know, but the g we know. G is a 9.81. Right? Where is g? G is 9.81. W equal to mg. And minus m we still don't know. A is 4. So end up we can find the mass of the root is equal to the 10.8 divided 5.81. Right? So 10.8 divided 5.81. How much? Okay, 10.8 divided 5.81. So equal to 0.0267. Right? So equal to 0.0267 kilogram. Okay. So 10.8 divided 5.8. What I'm doing just now. Yeah. Sorry. 5.81. Okay, so it's 1.86. Okay, sorry, 1.86. That wrongly. 1.86. 1.86 kilogram. Okay, so 1.86 kilogram for the mass of the root, and the tension is 10.8 newtons. All right. Okay, so only the difference is when it asks about the this one C is what? C is the resultant force acting on the trolley. All right. So if you're asking about resultant force on the trolley, then the resultant force will be equal to MA. So with the mass 1.2 multiply the force, so the resultant force is equal to 4.8 Newton. Right? So that is answer for the resultant force 4.8 Newton. Okay. So hopefully that you learn solve in that way. So if you don't know the concept, so you will confuse why suddenly have these equations, right? And why suddenly have these equations, right? So hopefully that you understand, okay? Because we're going to see it as a two different methods. We're going to see it as a two different systems. Sorry, two different systems. We split it from the center of the connections. All right. Okay, and then these solutions of forces is only is about how you dissolve a single force into the two perpendicular components. Right. Okay, so this one actually is a reverse methods from the parallelogram. Remember just now? Okay, when you have the ones horizontal force, okay, and another one vertical force. Okay, so perpendicular. In this case, right? In this case, let's say I put this one as fx, this one is fy. So when we apply the parallelogram, so you're going to draw another one parallel with fx, right? Draw another one parallel with fy. So these two parallel, right? Parallel with fx and parallel with fy. So from here, we get the resultant force acting in this way, from the starting to the endings here. So this is your resultant force. Okay. So in these solutions of forces, okay, it's about when you are given a force, right? When you given a force like this example, when you given that this is a one force. So let's say this is F. So this F, we're going to dissolve it into two components. One will be the horizontal, another one is the vertical. So this is the one that we're going to find, Fx and Fy. So these two we're going to present the force given. Just like the resultant force is the one solution, it's single force represented the two forces Fx and Fy. It's the same thing, only with the barikan. Right? So why we need to do this dissolve the force into the two components? Because we're going to solve it with the other forces, which is they are not in parallel directions. Right? So this basically is about the calculations method. So just like example, okay, so let's say I have a force, two forces only. Okay, let's say I have the two forces only. Okay. So let's say there's an example. Here I have the 10 Newton. Then another one with the angles of 30 degree. So I have another force acting this way is let's say it's a 12 Newton. So when we want to find what is the resultant force acting on this point, right? So we have the options. Either we solve it by drawing method or either we solve it by calculation method. Calculation method will be these solutions of forces. Okay. If you want to solve it by the drawing methods, means that we're going to draw another parallel line. Okay. At the ends of this 10 Newton. Okay. And afterwards, you're going to draw another parallel line with the 10 Newton. So remember, these two parallel lines, we must fix the ratio. Right, with the size of the paper that you have for this one 10 and 12 Newton, maybe you need to fix a 1 centimeter represent 1 Newton. So later on when in your drawing 10 Newton, make sure you draw exactly, you have to measure exactly the 10 centimeter. This one you have to measure exactly 12 centimeter to present the 12 Newton with the angle of 30 degree. So all the line have to follow exactly the same. Then you will get the answer for the resultant force, okay, from here to here. This will be your resultant force. Right? So because we follow the error, so the error here and error here, right? So that's why it come to this point. So from the white color point come to the yellow color point, there's an actions of the resultant force. Okay. So this is a solution by the parallelogram. All right. We also can solve it by the triangle forces method, by drawing also. So triangle forces method means that you need to draw the, usually as I said that usually we start with horizontal or vertical easier. So we draw the 10 centimeter exactly. All right. So this one exactly 10 centimeter to present 10 Newton. Right. From one point, starting point here to the ending point. Follow the arrow. Oh, and then in this ending point, so we continue. At the ending point here, we continue with the 30 degree. We draw another one, 12 centimeter. All right, 12 centimeter. We get another 12 centimeter, 30 degree. Follow, measure the angle, and measure the length. All right, so this is will be 12 centimeter with the angle 30 degree from horizontal. So this one you have to be careful lah. Okay, so once it's ending here, then starting to ending point have the gap. So for the starting point to ending point, the gap, close the gap, there will be the resultant force. So this one we call it triangle forces method. So you find the resultant force. Measure the length, measure the angle for the horizontal line here. Right. So this angle you're looking for, right? And you get the answers already. All right. So these two are the drawing method. So if you want to solve it by calculation method, so once you have the force with a specific angle, then you need to dissolve it. Right, so you need to dissolve it so that it will end with the two final x and y component. Once you have the final x and y component, so you can easily solve it by the what's it called that? It's solved by the right angle triangle, the theorem particulars. Okay, particulars theorem to find the hypotenuse formula. All right, x squared plus b squared to c squared. You can easily solve it. Okay, that is the reason why we need to dissolve it into the x and y component. All right. So like the case here, I repeat again the questions. So if you have 10 Newton in this way and 12 Newton with a 30 degree theta here, so you need to find this one, the solution presented for this 12 Newton. So you need to know what is the fx and what is the fy. Okay, so this one will back to the understanding about the right angle triangle lah, right? Right angle triangle, when you have the theta here, where this one is the f, so you have the fx in this way, you have the fy in this way. So fx will equal to the f, okay, cos theta, and fy will equal to the f sine theta. Right? So with that, so then you will know here, this one you can erase already. All right, this one erase already. This one also erase already. You just need to write what? You need to write here is 12 cos 30 degree. This one you have to write here 12 sine 30 degree. So once you've done these two already, then for the original 12 newtons with the 30 degree here is no longer exists. We don't need to care about this anymore because it's already dissolved into the two components. All right, we are dissolving into two components. So now these two presented our 12 Newton. Right? So now you see we have the parallel force. Our parallel force is what? Which is we have the parallel in horizontal, 12 cos 30 to the right, 10 Newton to the left. So do your calculation. 12 cos 30. 12 cos 30 is 12 multiply 12 multiply 0.866. So equal to 10.39, right? 10.39 here. So we have this one equal to 10.39 Newton. So it means we have resultants on the x-axis, okay, is 0.39 Newton to the right. Okay, 10.39 minus 10, so we have the 0.39 to the right. Okay, and then vertical, just only the remaining one is only 12 sin 30. So 12 sin 30 will equal to 6 Newton. Right? Okay, so we have these two. Once we have these two, then we can apply our right angle triangle or the simple parallelogram like this. So you have the resultant force in this way. So the resultant force will equal to the square root of the 0.39 square plus 6 square. Then you square root it, we get the resultant force. All right, so there's the answer. And the theta, so theta will be the tangent. Theta is equal to the 6 over 0.39. So from here, you can find the theta by the calculations. Okay, so this is dissolution forces methods basically used to calculation. All right, so this is what I mentioned just now. Okay, hopefully that you understand about these methods. Okay, and then the next one, we have the objects on the inclined surface. Right, objects on the inclined surface, you have to be alert the meanings of the normal direction toward the surface. Normal direction towards the surface. Normal means it's 90 degrees. So once your surface is inclined, so follow the surface, you get the 90 degree. Okay, and then okay, okay. More important is that you have to understand about the free body like this. Ayo, no sorry. Okay. All right. Where is it? Okay, here. So remember, no matter the objects on the horizontal surface or the objects on the inclined surface, it will always experience the vertical downward weight. Only when the object in the exactly on the horizontal surface, the weight, it doesn't affect the motion of the object move in the horizontal, just like the trolley just now. Okay, but once it's in the inclined surface, so the weight still vertically downward, but now because the inclined surface, so the weight will given the effect on the motions of the object on the inclined surface. So the effects of the weight here, we have to find by the x components, weight components here, wx, right? Components of the weight. Okay, component of the weight here. So this is one is a mg, w. So here wx will equal to the mg, okay, since 60. Because the angle here is 60 degree, this angle. All right, so just remember this lah. Okay, but if given the other side angle, so if the other side angle here, let's say the blue color, on the other side angle here, let's say this one's a theta, so theta by right 30 degree, right? So because 60, 30, then this components of the weight on this surface will become mg cos 30. Right? So you have to understand about the apply on the sin and cos lah. Okay. So there's this one. Okay, here is the explanations about how we get this theta, and the components of weight in this way is effects on the sin theta. Right? Okay. And the forces in equilibriums. Forces in equilibriums means that we are studying on the objects hanging at rest, hanging and stay at rest. So when object hanging stay at rest, so because of the string is hanging support the weight of the object, then for all the string experience the tensions, right? And all this tension is going to balance with the weight itself, right? So that's why the resultant force is 0. That is why we call it forces in equilibrium, because the forces acting have acting on the object produce a 0 resultant force. This is what we call equilibrium. It's just like the way we understand the last year Form 4, Chapter 4 about the thermal in equilibrium. So thermal equilibrium means there will be the not net heat transfer. Net heat becomes 0, right? So same also equilibrium of forces. Our net force or we call it resultant force, is equal to 0, right? So doesn't mean there's no forces. You still have a forces acting, only the resultant force for the forces acting becomes 0. That's what we call in equilibrium state. So the object will stay at rest. All right. Okay. So here's the example. So in this case, definitely we're going to solve it by these solutions of forces. It will be easier. All right. For this solution of forces, one of the methods you have to remember, everything we start on the x-axis and y-axis. So we put everything into this x and y-axis. Okay, so we have the vertical down is a weight 4 Newton. And then we have the horizontal as given the ligand 3 Newton for the center, 3 Newton. And then we have the tensions. Okay, we have the tension T, 5 Newton. All right. So in that case, we need to know how much is the anchor. Let's say we put a theta here. In this 3, 4, 5, they are in perpendicular. They are in equilibrium. So we're going to find what is a theta to prove the result. So with the theta here, then we're going to focus on this 5 Newton. Because 3 and 4 is already in the vertical and horizontal, so nothing to do with them. So just only this one is not in vertical, not in horizontal. So we need to do the dissolve it into the fx and fy. So we have this one, fx in this way will be the 5 cos theta. And then we have this, okay, measure two components when you dissolve the force. So we have the phi, okay, we will have the phi sin theta here. Okay, so then now we can erase it. So these two become the forces, the dissolution of forces to present the 5 Newton. So with that, we can solve it now, okay, because we know that the 3 Newtons must be equal to the 5 cos theta. All right, so to find the cos theta must be the 3 over 5. So the theta must be the shift cos 3 over 5. So use a calculator to find the answer. Or you can solve it with this, with the 5 sin theta must equal to 4. Upward must equal to downward magnitude so that they have a resultant 0. Okay. So the sin theta will equal to the 4 over 5. Then the theta will equal to the shift sin 4 over 5. All right. So either one, it will lead you to the same answer. All right. Either one you solve it, it will lead you to the same answer when you want to find the theta. Okay. So there's some example. Okay, for the forces and equilibriums. I think the last year we have a question for that. I say if I'm not wrong. So here you are. Here's the ones. Okay, what's the meanings of words? Okay, and then here. Okay, a few seconds after the bending is hang, is found that the string of the bending is snapped. Okay, by using the values of theta 30 degree. So calculate the tension of the string and the resultant force. Explain why the string is of the bending is snapped. All right. Okay. So okay, it's told you that the string can support. Okay, can withstand the maximum of 10 Newton. All right. So the weight of the bending is 15 Newton. So now we have this one. The weight is 15 Newton. And then the bending, okay, we don't know how much that supports. We know that there's a tension with the angle 30 degree. So, okay. And then it asks you, okay, explain why the string of bending. It asks you calculate first, calculate the tension, and explain. Calculate tension and resultant force. Okay. So now, see, okay, so in this case, they have a two different way. You study carefully. The question asks you calculate the tensions and the resultant force. All right. So first one, if we calculate the tensions, then we will make it based on the equilibriums. So from here, later on, how to find the resultant force, we have to look at the maximum of force. Tensions can be, the string can be withstand 10 Newton. So we do it first one by one. Okay. So in the case, we have the x-axis and y-axis. So we have the vertical down 15 Newton. And then we have this one going this way with the theta 30 degree, 1T. And then we have the second one going to the right side here. So also tension 30 degree. So we don't need to split as a T1, T2 because they're actually the same angle. When same angle, both sides the T is the same. All right. So end up, okay, when we do the dissolution of forces, so we have this way T cos 30, and this one T cos 30. So nothing to prove, we only prove that they are same horizontally, opposite directions, so they cancel out each other. All right. So X component done. Only we left a y component. Y component, when we dissolution of this one, we have go this way, have the T sine 30, and another one T sine 30. So end up we have the 2T sine 30 degree equal to 15 Newton. So the T will equal to the 15 divided 2 sine 30. Right, so it's a 7.5 divided by the 0.5. So at the end, it's still back to 15 Newton. So the tension is 15 Newton. Tension now is 15 Newton. Okay, but the maximum can support is only 10 Newton. Right? So you have the resultant force, 5 Newton. Okay, each tension is this one. Each tension you have here, SPM each tension here, 15 Newton. So, but it only can support 10. So you have additional, you have the resultant force 5 Newton extra. So this 5 Newton is the one to cause the pending drop. All right. So I see what's the explanation given here. That one is the question what? Question 9. Because there's two different ways to solve. So as I said that the tension is 50 Newton. All right. So it wasn't show the resultant force. Okay, it's only show the tension is 50 Newton. Okay, so like that 4 marks, I don't believe because there's no explanations. All right, so I don't think that's a good answer. That's why I told you, okay, answer just only the reference. So once you doesn't okay, not really feel that the answer given is fulfill the needs of question, better you ask. Okay, so in this case, it's only show the tensions. All right, it doesn't show the resultant force. So explain why the string of the painting is snapped. Okay, so in that case, because the explanation here is what explanation just only say that okay, the tension 50 Newton is exceeds the maximum force 10 Newton can be supported by the string due to the resultant force 5 Newton. So that's why okay, the 5 Newton it will cause the string snap. Right, so it should have an explanation, explain why, but the answer given is no explanation. So there's no explanation, and that's why I mentioned 4 marks. Crazy, right? So remember SPM standard, SPM standard, one calculation solution, maximum 3 marks only. They seldom one calculation solution, one solution give more than 3 marks. When more than 3 marks, it was split into 2 different calculations or the 2 different answers required. All right. Okay. So okay, and ask you to draw. Okay, the painting is broken when it's dropped from the height. So this one is mixed with the impulsive force already. All right. Okay. So okay, and then the next for the decision making here is also here to understand about the maximum tensions of the cable. Right, so you need to understand about the anchor, how to make become maximum tensions, right? And then it's looking for maximum tension is better, right? So you have to make sure the tension bigger is better, because when you have the bigger tension means that you were given the bigger forward force, so that you can pull the lorry forwards. Okay, so if a smaller smaller tension, then you have not enough force to pull the lorry move forward. Okay, so I think this one answer should be fine. Right. So the tension should be high. Okay, so that you can support a higher force, can produce a higher force. Okay, or maximum tension. Okay, maximum tension can support, so it should be higher maximum tensions lah. Okay, angle should be small so they can produce a higher force. All right. Okay, because once the angle is big, then from the diagram itself you can see when the angle 60°, so angle 60°, there's a T here, or this a force here, this a force here. So then the forwards here will be the F cos 60. F cos 60. Right? Compared to the smaller angle, another one is a 30°, right? So 30° is split the center. So you have the F here, you have the F here. So the forward will be the 2F cos 30. So cos theta, okay, when the cos 30 and compared to the cos 60, right? So cos 30 we have the 0.866, and then the cos 60 will be equal to 0.5. So the bigger the angle, it will be smaller. Okay, it will be smaller the resultant forward force. That's why the answer provided looking for the smaller angle. Okay, it will produce a bigger, higher force. Okay. Okay. This is a question related to the dissolutions of forces and also the resultant forces, resultant force. Okay, this is the first part. And then the second part about the elasticity. So elasticity, you need to know, okay, specific focus on the spring. All right. So before that, make sure they're able to explain the meanings of the elasticity. So and then after that, okay, is the spring system lah. Okay, spring system. All right. So spring system, we have to obey the Hooke's law. From the Hooke's law, okay, understand about the Hooke's law about the spring constant. From the graph itself, we're able to know the energy stored, okay, in the spring, which is we call it elastic potential energy. All right, is the area under graph. So that's why we have the 1/2 Fx. Okay, 1/2 Fx. That is the energy. So due to the K is a spin constant, which is F equal to Kx. So once you substitute the formula, then we have the elastic potential energy is equal to 1/2 Kx squared as well. All right. This one from the beginning I told you already. Okay. So now I just want to make sure they understand the concept here. Okay. The first one, okay, you have to understand what's meaning by the stiffer spring, what's the meaning by the softer spring. All right. So let's say here, okay, there is Fx here. Right. So example like this, I have the spring P and I have a spring Q. Right. So may I know which one is the stiffer spring? Okay, P and Q, which one is the stiffer spring? So if I give you a graph like this, which one is the stiffer spring? Or which one is the stronger spring? Can support bigger weight? Which one is the stiffer spring? Igoroshini, Q. Okay, stiffer spring means that the spring constant of the spring is higher or lower. For the stiffer spring, the spring constant is higher or lower? All right. When we're looking for a stiffer spring, we are looking for the higher spring constant, which is you need more. We need more force only can extend the spring. That's what we call stiffer spring. Right? We need more force to extend the spring. Okay. To understand the graph here, you have to be careful. Look at the graph. It's given as this is what? Is the F against X or X against F? Right. So since the graph I given here is a F against X, so you can deferring here with the same X. With the same X here, you can check. Okay, so yeah, with the same X here, you can check. So this is the force of the FQ. Force for the Q for this extension. But the force for the P will be more. So it means that the P need higher force to get the same extensions as a Q. So from here, P is the one that we call it stiffer spring because it need more force. And with the formula F equal to Kx, means that the K is equal to F over X, means it's the gradient of the graph. So when the gradient is bigger, so it's showing there's a stiffer spring. That's why if we prove with the gradient, still the spring P is the one stiffer. Okay, so now with the same graph, tell me which spring, the diameter of the spring coin, I repeat again, between P and Q, which one the diameter of the spring coin is bigger? Which diameter of the spring coin is bigger for the P and Q? Right? So Isabel's answer is correct. Okay, yes, evolutionary, finally you get correct answer also. Right? Beginning you're wrong, huh? Right. So when I asking about the spring coins bigger, means that one is referring to the softer spring. So softer spring will be Q lah. Okay. So next one, which spring actually, let's say both spring is the same, how to say that? Same material. All right. So same material, same diameter of the spring wire, same diameter coin. So which spring is longer? Original length. Which spring is longer? It's a Q again. Right? Yes, it's a Q again. Spring Q is longer. Right? Long original length. Because the longer the spring itself, it makes the spring become softer. Right? It makes the spring become softer. Okay, and the diameter of the spring wire, which one is the thinner wire? Which one is a thinner wire? Or the smaller diameter of wire? Right? Why suddenly all get wrong already? I asking about thinner wire. When the spring wire is thinner, it makes the spring softer or stiffer? When we use a thinner wire to make spring. When you use thinner wire to make spring, it will make the spring become weak spring, or we call it softer spring. So the answer is still the same Q. So be careful about the two different kind of diameter. Last week there's one teacher asked in the group. So asked to explain what's the difference between the diameter of wire and diameter of the spring. So the teachers confused with the terms of diameter. We're talking about diameters of wire, so we're talking about the thickness of wire to make spring. We're talking about the diameter of the spring coin. So when we use the wire make the springs already, the spring have the diameter, it's a coin diameter. So these two diameter, it will result in the different way. When you have a bigger diameter of coin, the spring coin bigger diameter, so you make the softer spring. When you have the smaller diameter of wire, means you're using the thinner wire. Thinner wire, it will make the spring softer also. All right. So bigger diameter of coil, softer. Smaller diameter of wire, softer. All right. So please be careful. The factor affect the stiffness of the spring. Okay. So now the next one, I'm going to ask you to do some calculation with the spring system. All right, with the spring system. So I don't make it too complicated. All right. Okay. Example. Okay. All right. So you are given identical springs here. Identical spring. Original length for the each spring is 10 centimeter. And it give you the example where the spring is hang with the root 500 gram. So the length of the spring extend to 12 centimeter. So now with the arrangement given in the diagram on the left here, so I want to know how much is the mass. Okay. So maybe I give you 5 minutes. Oh, no, the 16. Sorry, I make some change. Sorry. I do wrongly already. No, not 16. 15, sorry. 15 centimeter. Okay, 15 centimeter. All right. Okay, it's 15 centimeter. All the spring are identical. Try tell me how much is the M. I give you the hints. First, you need to know what is the extensions of the spring system. The 15 centimeter is based on the how many extension. This is the first one. Second, you need to know also, okay, how much the mass it will make the change of 1 centimeter. Can do or not? Two minutes, 3 minutes over already. Right? Anyone got the answer? Okay. First one, we need to know this 15 centimeter, how we get. This 15 centimeter actually equal to how many original length and plus or minus extension. Plus or minus extensions. The spring now is a compression system, compressed, so it should be minus. All right, so minus here. And how many original length? To find this 15 centimeter, it based on how many original length to minus extension. 20 original length. Isabel, seriously? 20 centimeter or 20 original length? 20 centimeter. So how many original length? 2 original lengths only. Later we only substitute original length as 10. So here's the 2 original length. Minus how many extension? Minus how many extensions? Anyone know? All right, so we have the 2 labels here, right? We have the 2 labels. That's why based on these 2 labels, we have the 2 original length. Okay, so this one, the label 1, we have the original length minus how many extension here? When the 2 spring arranged in parallel, how much the extension? Right, it's only half. So that's why here we got half extension minus half extension. This is the label 1. Label 2, also the original length minus how many extensions? So we have the 3 in parallel. So we're going to minus 1 over 3 x. So once we total up it, so it becomes 2 original length minus 5 over 6. So because 1 over 2 plus 1 over 3 is equal to 5 over 6. Right? So this 15 centimeter is equal to the 2 multiplied 10 minus 5 over 6x. All right? So it means that our 5 over 6x is equal to the 20 minus 15. That's equal to the 5. So the x will equal to the 5 multiplied 6 over 5. So the x is equal to 6 centimeter. So this x is equal to 6 centimeter because of this mass m. So now we can solve the problems already. Mass extensions. Originally, it tells us every 500 gram, it will make the extension 12 minus 10. It will make the extension 2 centimeter. So now with the m, we don't know, but extension is a 6 centimeter. So from here, we know that it's going to multiply 3, become 2, become 6. So 500 gram also going to multiply 3. So then the m will equal to 1,500 gram or equal to 1.5 kilogram. So this is how we solve. All right. So that's why you need to know the system got how many extensions. That's what I mentioned. That's what's the meanings that I told you. All right. You need to know how much is the extensions of the spring system. Can you understand the solutions? If yes, please raise your hand. All right. So now we see last year got the similar questions or not. Look at the paper one. Paper one, so inclined surface. And this one, I think so. No, not spring system at all. Paper two, I don't think so about spring system. All right. So last year paper two focused more on this resultant force, dissolution of forces. So maybe this year they will be focused on the spring. Right. So obviously there's nothing to do with the spring at all. Right. So if they want to have a questions in the chapter 1 force and motion 2, then definitely they're going to design the question about the spring. All right. So you may need to study more on that. Okay. So that's all for the chapter 1. Okay. So everything's I already touched, includes the extensions, the spring system, parallel or series. Just only I do it in the different way. I do it on the compression system so that the extension will cause the spring become shorter. But if you hang it, stretching it, so it will be make the spring become longer. But the way we solve is still similar, just only plus and minus the extensions. Okay, so hopefully that you learn something with the question that I discussed just now. All right, so is that okay for the chapter 1? Can proceed to chapter 2. If yes, please raise your hand. Okay, and then regarding the elastic potential energies, elastic potential energy with the formula provided here. I just want to remind you regarding that. Where is it? Here, this one. So because we are calculating about the energy, so please remember, be careful. Make sure the X must in units meter. Cannot be centimeter, cannot be other than meter. Because we're going to find the answer in unit joule. In unit joule, SI unit for the energy. All right. So please be careful, especially when you apply the spring constant substitute K. Because usually we will give you the spring constant as with the unit how many Newton per meter per centimeter. How many Newton per centimeter? Because in our applications, our extension just only up to few centimeter. So to make calculation easier, to know how much the extension, that's why usually the spring constant we measure with the unit Newton per centimeter or Newton per millimeter. We seldom really tell you the unit in SI unit with the Newton per meter. So when you substitute to find the elastic potential energy, so just be careful lah. All right, make sure the unit of the length converted back to unit meter, especially when you substitute with the formula kx squared. So make sure the x and the k all in unit meter, and the x must be x squared, right? So don't forget. So when you write the formula, please write bigger in your handwriting, right? So that you won't missing any, especially the power. Either it's a square, either it's a cube. Example like the chapter 3 gravitations. So the formula, make sure that you don't forget about the square, don't forget the cube, and even the power of 4 sometimes, okay, for the Kepler's law. So please be careful. Okay. All right. So the energy will be the unit in joule. So and then this energy, when we compress a spring or we stretching the spring, so the energy stored inside the spring, when once we let go, so it will be converted back into the kinetic energy. All right. So with the mass of the object, we make equal to 102 mv squared. So from here, we're able to know what is the theoretical maximum velocity can be reached by the object when it's launching by the compression spring or it's launching by the stretching spring. So we call it maximum velocity because we're assuming there's no energy loss. All right. So I listed the answer, the similar questions discussed. So there's no question discussed on that. So make sure you understand because we can do the calculation. Once the spring release by compress or stretching, so the object will experience the velocity. So because the converts of energy, right? So and then we call it maximum velocity because we assume there's no energy loss. All right, so that's all for the chapter 1. Okay, so next we go to the chapter 2. Okay, chapter 2 will focus on the calculation about the pressure. All right, so there's a few different pressure here. Okay, pressure. So also, Sam, we're going to split this chapter into 2 different parts. So first part, we will focus on the calculation about the pressure, either the pressure in liquid, pressure, atmospheric pressure, or the gas pressure. Second part is about the 3 different principles, right? 3 different principles also related to the applications of the concept pressure, right? Okay, so pressure in liquid, okay, we look at the formulas here. Okay. So last year there are not much questions about the instruments, instrument to measure the pressure, right? So from the question you see, there's one the manometer here, right? Okay, the barometer. So barometer, and after that I think it's no more. Okay, so applications of this one for the Pascal principle. Okay, due to the piston, how it works, for the hydraulic jack, Pascal principle. So instrument about the manometer doesn't have, it's only have a barometer. Okay. So I close this one first. Okay. So look at the formula. So it provided the general pressure formula, P equal to F over A. But from the beginning, there's not given in the textbook at all. Because in the textbook, it straight away discuss about the pressure in the liquids, right? So how we convert this P equal to FA into the P equal to H rho G, which is the pressure, how we determine the pressure in liquids. So it show you the derives the formula from the general pressure, okay? So this is the pressure that there's a formula we use to find the pressure in liquids, right? So there's no formula for the determine the pressure of gas or pressure of the atmosphere pressure, because we can't calculate it. We only can use instrument to help us get to know about the gas pressure and atmospheric pressure. That's why atmospheric pressure and gas pressure, we're going to learn instrument, the calculation based on the instrument. Okay, it's not based on the formula. on the formula is only the pressure in liquid, right? Hash rho G. All right. Just only be careful about the hash. Make sure the hash is measured from the surface of the liquid down. All right. Okay. And another one that will make the student confused is about the calculation when we're going to include the atmospheric pressure acting on the surface, when it doesn't need to include. All right, so let's see about the example. Okay, so like this one. This one's for the YouTube. All right, YouTube. Okay, so this one later. Okay, here example you see. Okay, what is the pressure experienced by the fish caused by the water around it? All right, it's caused by the water. It's mentioned very clear. Caused by the water. Caused by the water. All right, so that's why I'll focus on the waters only. And after that, you have another one question. What is the actual pressure? So actual pressure means it's not only caused by the water itself only, it's also includes ATM. This will become actual pressure acting on the fish. Because when it caused by water only, when the fish on the water surface, so there's no any water pressure act on the fish, but the fish is still experiencing pressure. When it comes to the surface, the fish will experience atmospheric pressure. So that's why no matter you are on the water surface or inside water, the calculation it should include atmospheric pressure. All right. Okay. So depends on the way how the question asking. All right. So just be alert. But as I mentioned, when the question given atmospheric pressure how much, so means that you have to include it. You have to include it. Right. Because of what? You look at the constant value here. Constant value here, it doesn't provide us. It doesn't provide us the atmospheric pressure. Right. So atmospheric pressure only provided when the question need you to use it. All right. So we see the other questions here. Example. Okay, what is the atmospheric pressure in the underground mines here? So here. It's told you inside the vacuum here. So it costs 90 centimeter. So when you go underground, how much atmospheric pressure? Why it said atmospheric pressure? Because barometer is only work when there is a pressure add on the surface here. And because it exposed to the surrounding, so that's why the acting on the surface here is the ATM. Because of the ATM pressure, then it will be force the mercury rest into this glass tube going up. So they can hold, the ATM can hold the mercury up to this height. So it means that at this moment, the pressure at here, same as the pressure acting on the surface. So and inside here is a 90 centimeter mercury that we have. So means atmospheric pressure will equal to 90 centimeter mercury. All right, so that's very easy. That's all with our answer. Okay. So and then the next one here, diagram show the two aquarium, right, with the different shape, filled with the water at the same level. Okay. So the pressure of the fish influenced by, so pressure on the fish, right, is the pressure in the water, pressure in the liquid. So it's a H rho G. So now you see, is that the volume involved? No volume involved. Is that the mass involved? No involved. Is that the diameter involved? No involved. Is that the depth of the fish involved? Yes, H is the depth of the fish. So that's why the answer is D. That's all. Very easy. All right. So if the question asks like this, don't be surprised. This is the SPM standard. Basically, most of the questions will be like this. It seldom have a question all like the questions 19. No need to worry. Question like the 19, maybe only 2 or 3 questions. Right. So the rest is very basics. So you should make sure you score the paper 1. All right, as high as possible. Try to control your mistake less than 5. It's possible, try to control mistake less than 3. Maximum I give you have a chance to answer wrongly is 3 questions. Once you're able to do so, then it shouldn't have a big problem for you to score at least A minus. All right. Okay. So, but once you have a wrong answer, wrong questions more than 8 items out of the 40. So to ensure the N minus, all right, I wouldn't say there's no chance. The chance is still there. Depends on how you perform the paper 2. All right, okay, but it's quite difficult already. All right, so try to control less than 3. That's why you need to do more authentication. Okay, so here's a picture in the liquids about the heterology. So make sure you understand. Okay, when the same type of liquids, like example, this one same type of liquids on the same level, they have the same pressure. So, but the pressure is calculated from the surface down. Okay, so when at the surface here, this is an oil here, on the other side also oil. So it means that this level, the pressure at this point, let's say I put the X here, the Y here, the pressure X and Y is the same. But the pressure X because of the water. So we have the pressure of the X, we have the 15 centimeter water H2O. Right. But the pressure Y, we have the 16.5 centimeter oil pressure. Right. So due to the different type of liquid, so we have the different density. So that's why here is a 15 multiply the density of water multiply H2G. Okay, on the other side, we have the 16.5 oil. So 16.5 multiply the density of the oil and multiply the G. So G and G cancel, right? So that's how we solve. Then we have given the density of water, so 1000, then we can find the density of oil easily. So this is how we understand for this U-tube, or we call it manometer. Okay, so higher the bigger the hash, so the deeper the water, higher the water pressure. Okay, so next one is atmospheric pressure. Atmospheric pressure, you need make sure you understand about this mercury barometer. All right. So as I explained just now, okay, it's about how strong the ATM can be hold the mercury inside the glass tube, right? So once you let go, okay, with this length or this height of the mercury inside, definitely it will be more than ATM. So that's why when we remove the dips, right? Remove the dips, so the mercury will fall. Okay, because in this moment, a level here is unable to hold by the ATM. So once you're going down until it's same as the ATM, so it will stop. Right. So once it stop, we notice it's a 760 millimeter. So this one, that's to make it easier to calculate. So we just only based on the length. So we change the unit pressure of ATM. We call it as a length of mercury. So we have a 760 millimeter mercury Hg. Right. So once we want to present the answer in the unit Pascal, so we need to do the calculation by apply the formula pressure in liquid H rho G. All right. So we have the radius of the units other than the length of the liquids as presented the pressure in the liquid itself. We also can use, okay, another one unit we call it bar. Okay. So where is it? Here. So either it's a Pascal, it's a SI unit, or either based on the length of mercury, or either based on the length of water, how many meter H2O, or either we use the mini bar, or we in the short form in the symbol will be M bar. Okay, so 1 mini bar equal to the 1 H Pascal. Okay, so or actually 1 bar equal to 1 ATM nah. 1 bar equal to 1 ATM. So this one just I think the knowledge. SPM is seldom asked about the unit of bar. So bar actually is applied in our industrial because our daily surrounding atmospheric pressure is 10 power 5 Pascal. So if we're still using the Pascal to measure the gas pressure contained in the containers or what, so the Pascal unit become very small unit. It's just like when we want to know about the distance from the JB to KL, we're not going to use a meter, we're not going to use a centimeter because the unit is just too small. So that's why we use kilometer. Same also for the measuring the pressure in industrial, okay, because surrounding atmospheric pressure 10 power 5 Pascal. So if we still using a Pascal, then will become very small unit. That's why usually they will apply how many bar, because 1 bar equal to 1 ATM. All right. Or 1 bar equal to the 10 meter water, 10 meter H2O. Okay. So 10 meter H2O equal to the 1 ATM. That's why 1 bar also equal to 10 meter water. And if we look at the watch, when we buy the water resistant watch, sometimes it will mention there how many bar, or sometimes it will mention how many meter water. It's showing that the watch can go to the deep of water, either can use it for the diving or not. Because the water pressure bigger, it cannot withstand, so the watch will be destroyed because of the water will go in. Right. So that's what we call how many water resistant, how many meter. Right. Okay, and then you need to know some knowledge about the effects of the high altitude with the low atmospheric pressure, and also the effects on the high pressure in the deeper water here. All right, under the sea is for the high pressure, above the high altitude on the climbing the mountain. So it will be high altitude, lower atmospheric pressure. What is the effect? Okay, higher pressure when you go to the diving, higher pressure, what's the effect? So all this you need to study, because once the question may ask, okay, the question may ask in essay, ask you to explain, okay, about the design, about the decision making. So you need to know, use it into the design. Okay, so for the gas pressure, the manometer, as I explained just now, okay, so in the case you see, right, the pressure at the B is not only the pressure due to the water itself, hash water is also include ATM, right? So the surface here, we already know that. Okay, if let's say I want to get this answer, all right, answer pressure A, same as the pressure B, and I want to give the answer in the units length of water. So remember, ATM surface, ATM itself is equal to the 10 meter waters already, 10 meter H2O. So plus this hash meter, so the pressure A will equal to the pressure B equal to the ATM plus the hash water, H2O. Then it will become the 10 meter H2O plus hash H2O. Depends on the how much is the hash, right? Okay. So in that case, you have to include atmospheric pressure, because when the moment they are same level means that both sides experience the same atmospheric pressure. If the gas cause A and B same level, then gas pressure same as ATM lah. So it's already given here. All right. So I didn't notice. All right. Anyway, it's already given. Okay, so this is about the gas pressure. I think nothing much. Okay, I'm going to discuss. If you got something to ask, you can ask in the group or just PM me. Okay, Pascal principle. Make sure you're able to explain the definitions. Okay, for the Pascal principle. Right, what is stated by the Pascal principle? This is one. Okay, state that the pressure applied on the enclosed fluid system, it was transmitted uniformly in all directions. Transmitted uniformly in all directions doesn't mean that it was divided through the various values, right? It's not like that. It's transmitted uniformly. It means that every part in the enclosed fluid system, it will experience the same pressure that apply. Pressure applied, not the pressure due to the depth of water itself, due to the fluid itself. No, it's a pressure added, pressure applied, pressure added into the system. All right. So we have the hierarchy system here. All right. So in this case, okay, we're going to apply the formula is not providing because we apply the concept as the pressure transmitter. So the pressure experienced here, same as the pressure on the experience on the other side. P1 equal to P2. Right. P1 equal to P2. Pressure defined as a force over area. Right. So that's why F1 over area 1 equal to F2 over area 2. Right. So we're going to apply this ratio due to the same pressure. Right. It's already given here. Then one thing that you have to know, this one, A2 over A1, we call it multiplying factor. Okay, A2 over A1, we call it multiplying factor. If I'm not wrong, last year got question asked about some terms. Okay, I don't know what factor they asked already. This one I see. This one. Okay, for the this transistor circuit. transistor circuit, it got asked about this. Okay, amplification factor beta. All right, so you suddenly use this term. If you don't know what's mean for that, so definitely cannot do a calculation. Even it's very simple. Like this one is a suddenly question asked. Okay, calculates what is the multiplying factor for this hydrolytic system. Then die. You don't know what's multiplying factor, so even just only simple A2 over A1, because there's no any references, you don't know, then you cannot solve. Right, so be careful all this name of the terms lah. Okay, and applications. So last year it got asked about the applications like this one. Okay, like game 18, question 25 here. Show the hydrolytic jet model. Okay, the pressure existed at the R is 150 Newton. So R 150 Newton. So what's the maximum weight could be lifted by the large piston? All right. So it give you the length, the area here, 200 centimeter square, right? And then the R is 150 Newton per centimeter, the pressure. All right, 150 Newton per centimeter. So how much is the maximum? All right, so given the pressures already, so it means the pressures from inside equally. Then we apply P equal to F over A. So F will equal to the P multiply A. So pressure given already. All right, so here's the pressure 150. Then multiply this length, the area is already 200. So this is the maximum force. Okay, so the answer will be the answer D lah, just like that. Okay, not difficult at all. Okay, I think that's all for this Pascal principle. So the next one is the Archimedes principle. Okay, I know that many of you worry about the Archimedes principle. First thing, you have to make sure you can spell it correctly. All right. So IEE, right, make sure it's all correct, because usually students know the answer, but the spelling is wrong. So that's why they cannot score. All right. Make sure you don't simply change the scientist name. Okay. So the buoyant force is this one actually is also part of the balance unbalance forces resultant force. All right. So remember, the object have the weight. So when immersed in the water, you experience the buoyant force. So when the buoyant force same as a weight, so the object floating, because it will cause the resultant force 0. All right. So the problem is when it's floating doesn't mean that it must on the surface above doesn't touch the water. You have to understand, it only experience the buoyant force when you immerse in the water, because the buoyant force is based on the weight of the water or weight of the liquid immersed by or the depressed by the object when immersed into the water. Okay, so when the object fully immersed, then the buoyant force experienced by the object will be maximum. There's no chance to gain any extra buoyant force, because once the object fully immersed, there is a maximum volume can be depressed. Therefore, the weight can be depressed by the object is already maximum. So that is the weight depressed by the object fully immersed. So it's the one that maximum buoyant force can be gained. All right. So all the calculation no need to worry, right? Okay. You just need to know. You see, okay. It doesn't have any special formula for this Archimedes principle provided. I also very surprised and get shocked. Okay, why it doesn't provide it? All right. So because it provided you the density here, right? So when you provide the density, so you have to pandai sendiri and find the formula to calculate the buoyant force, right? Okay, because here you have a F equal to P multiply A. So F equal to what? Okay. So what is the pressure? H rho G. All right. So pressure is H rho G. So you have the H rho G multiply A. And the rho is what? Rho is M over V. So you have the H multiply M over V multiply G A. All right. So V is what? V is the H multiply area, cross-sectional area. So H and H, okay? H and H cancel already. So and you have the mass over area. So once you have the mass over area, okay, A and A also cancel. Hey, what I'm doing? I repeat. I write too small. Okay, let me repeat again. Sorry, I made you confused. Okay. Once again, how to find the buoyant force? Okay, from the concept here, pressure multiply A, so it's a hash rho G multiply A. So okay, and then the problem is hash and the A here. Hash and the A both is the length. When the A is a cross-sectional area, cross-sectional area multiply this hash, it becomes the volume. So we have the rho Vg. So this is the one that to help us to determine the buoyant force. Okay, rho Vg. Rho Vg is the one to determine the buoyant force. It depends on the how much the volume immersed, or how much the volume depressed by the objects when immersed in the water. And then density is the density of the liquids. So usually we will use the water lah. So that's why we sometimes we will just only mention density of water. So here's the formula. Okay, resultant force. All right, which is the buoyant force. Okay. So you have to understand the situation as I mentioned just now. When the object is floating, free floating, so means that the buoyant force equal to the weight, resultant force equal to 0, so it will remain at the position. That's what we call floating. Either it's fully immersed, exactly below the water level, or actually in the middle of the water, right? So when it remains stationary at the position, we call it free floating. So resultant force equal to 0, which is the weight equal to the buoyant force. But if the water is moving down, sinking, moving down to the bottom, so it means that the weight is bigger than buoyant force can be gained. All right, so then we have the resultant downward. Okay, so object will accelerate going down. Right, but when the moment the object experience the bigger buoyant force, so it will be lift because we have the buoyant force bigger than weight, so the resultant force will be upwards. The one will be cast on the right hand side here, so it will lift. When the moment it lift, when the moment it going up, move upwards. When it lift, when it come to the surface here, when it come to the surface, so it will reduce the buoyant force because now the buoyant force is based on this part of the water depressed by the object. So it will be less water depressed when it rests to the surface. Therefore, the buoyant force will decrease until the moment this buoyant force equal to the weight of the object, then it will stop. All right, so it will be floating, it will back to this one. Okay, so in the case for the understanding about the buoyant force, do not simply make any simple conclusion. Okay, I know that there are many teachers outside, okay, or the video that you watch, it keep mentions, okay, higher density gains more buoyant force. That's why when the man's immersed in the seawater compared to the man immersed in the fresh water, river water, so when you go to immerse in the seawater, it will easily float because you gain more buoyant force in the seawater due to the higher density of water. Right? These statements for me is totally wrong concept. When you go to the seawater or when you go to the fresh water, okay, or river water, if you are floating in either river water or either the seawater, when you are floating, you experience the same buoyant force. No such thing that higher density gains more buoyant force because both same floating. When floating, both have the same buoyant force equal to your body weight. And what's the difference? The difference is when you immerse in the seawater, you float higher. You float higher, so because you don't need that much of the volume, you don't need to gain that much of the volume, or you don't need to gain that much of the water depressed by the seawater to support you to gain your buoyant force. Okay, the statement said that the denser water can gain more buoyant force is based on what? It's based on the constant same volume immersed. When you have the same volume immersed due to higher density, yes, you gain more buoyant force. Because of that, you lift higher. Because you gain more buoyant force, so you have a greater buoyant force with the same volume, then you lift. Then you will get floating higher. The expression is correct. Okay, you must saying that based on the what is constant. You cannot just simply mention, okay, when you go into seawater, you gain bigger buoyant force because of the water is denser, right? So it's wrong, okay, because either when you're floating on the boat, you have a same buoyant force. Okay, so you have to understand the explanation and the situation. Okay, what is the term and condition must include. All right, so think more about this. It's, the problem that I told you. All right. Okay, so okay. This one, okay, many students when after study, so you were forgotten about this hydrometer. Hydrometer is an instrument we use to measure the unknown density liquids. Right? So we use it to measure the density. Because of the different density, it will change the buoyant force if it have a same volume. That's why I told you when you go to the higher density, it will be float higher. When you float higher, so you gain the same buoyant force as you go into the lower density liquid. Then from the volume change here, we're able to know, okay, we're able to know the value of the unknown density liquid. So based on the stem here, the stem, so that's how we label. So study on this lah. Okay, and if you want to make it more sensitive, we have to look at the stem have a smaller diameter. Because smaller diameter, it will make it narrow. So when there's a slightly change in density, it will make it bigger change in volume in mass. So it will show you the change in height, obviously. So it will be easier for us to reach the change in the small density change. Okay, so try to take some time to study about this hydrometer. Okay. So and then this one, the explanation about the submarine. Okay, so I think there's not that much challenging for you, right? And when you understand this already, so but both thing with the front and back so that we can change the anchor, right? So once you change the anchor with the engines, okay, so we when here backward here we immerse more water here, then we come the back part here become more wet, so it will be this one will be it will change the angle upwards. So when we exceed the force, it will make the submarine go up and go down. So this is how we control. Okay, one of the way. Okay, and then we also have the pencil line. Pencil line is the ones to the question is already designed for you in the trial. So go back to see the questions. Right, pencil line is to avoid the overroute. Okay, overroute because on the different options, review the different seasons, so they should have a one guideline to let the captain alert whether the cargo is overloaded or not. Okay, to avoid the accidents. Okay, and then the design of the hot air balloons. Okay, we have the penetrating valve, the center here. This one can be opened so that you can release the air out. So when the moment you want to come down, all right. So here's the explanation: how you're going up, how you're going down. All right. So try to read here. I think that's all. So as what I know, you don't need to too worry about the calculation part, because from the past year SPM, so when I go through almost 20 years of past year SPM, I noticed that the SPM they don't really like to ask about the calculations on the Archimedes principle. They just only more ask on the explanation, the concept. Okay, so calculation part, maybe the thing is difficult for students. Okay, maybe sorry to say so, maybe the thing also difficult for themselves to set the questions. Okay, nowadays you know that the questions, sorry to say so, no quality at all. Okay, so okay, and the Bourne principle even easier because there's no calculations at all, right? Bourne principle just only the apply of the concept. to knowing that how the speed of the fluid affect the pressure of the fluid. Okay, so Brownian principle states that when the velocity of the fluid increase, so the pressure of the fluid decrease. So it's inversely proportional lah. And then in the Brownian principle, one thing is very important you learn is this one, the aerofoil shape. All right, aerofoil shape. Okay, make sure you know how's the air flow through with the shape itself. And when we reverse it, okay, so actually you will producing the downward force. That one you call it inverted aerofoil. Inverted aerofoil, actually last year they asked already, huh? Inverted aerofoil, where is it? I think last year they asked already in the essay questions here. Yeah, here's the one. Okay, hydrofoil. They don't use aerofoil, they use hydrofoil. Okay, why is they call it hydrofoil suddenly come out? If related to the any air motion, we call it aerofoil. All right. So when related to the water, to the liquid, we will use hydro. So from this, when immersed in the water, so aerofoil become hydrofoil. Right. So don't be surprised lah. Okay. So with the hydrofoil, okay, so we can produce a lift force lah. It's the same concept. Only the aerofoil is specific on the airflow, it produces a lift force. When the hydrofoil immersed in the water, when it move the water with the water current, so it can produce a lift force, so it can make it lift higher. Right. So this is not the duck dicks, right? It's not the two duck inside, right? So this is a hydrofoil. So the drawing a bit ugly, Okay. So application of Brownian principle. So okay, this one I explained a lot already. So just want to highlight. Make sure you're able to explain to the ligands events. Okay, about the different pressure. Due to different pressure regions, you will create the resultant force from the higher pressure to a different pressure region. Okay, in this part explanations, the student always forgotten mention different pressure cause the resultant force. They always forgot to mention about different pressure. They only remember, okay, this region, the air flow higher velocity, therefore the pressure is lower. And then the other region, the air flow velocity is lower, then the pressure is higher. Therefore, you have the higher force, okay, due to the higher pressure. Then they always forgot to mention another statement, due to the different pressure on the two regions, therefore, there will be resultant force produced from the high pressure toward low pressure region. So make sure you mention that difference pressure, okay? Different in pressure to produce a resultant force. Due to the high pressure region have a higher force, low pressure region have a lower force, okay? So just only understand about that. So I think that's all lah, okay? So since the last year, they have a essay specific questions on the Brownian principle. So I don't think so this year they will ask again lah, unless you're really unlucky lah. All right, so I think this year they will be focused on the Pascal principle or Archimedes principle. All right, so okay, good luck lah, huh? Okay, if they ask more in Archimedes principle, so please be confident. Okay, recall back the concept. What's meant by the buoyant force, then how to understand about whether the lift force is produced or not, okay, or about the floating concept. So maybe you need to study more on the Pascal and Archimedes principle. All right, okay, so that's all for these two chapters. Okay, and tomorrow morning slot I may change in later I will try in the group. I may cancel the tomorrow morning slot. Okay, I need the rest already. So today I 4 hours talking. So since long time no talk already, so I need some rest. And another one is because of the tomorrow afternoons, I have another 2 different slots with my tuition students. So that's another reason. So maybe I will consider to cancel tomorrow morning slot, postpone it to the other slot. So later I'll inform in the group, see how first. All right, so that's all for these 2 hours. Can give some tips for suggestion, explanations, questions. I'm not the panel. Okay, all the questions can be asked for the explanations. All right, so maybe you need to go through the STF module. I think inside they have a lot of explanation questions. Right, you can try to learn through that. Okay, I think that's enough for you already. So if you can go through all the STF questions, okay? All right, so that's all for this